Good evening, class. Today I will be discussing my final project with you, Finding Fitness in Fredericksburg, Virginia. And I would like to just thank you all for taking the time to listen to this. And I would like to preface with saying by the time you all see this, there will be a link to this recording on this front screen here. So just some background in the goals of this project. The fitness industry has grown at a rapid 4% over the last 2 years. This demand has caused gyms to pop up all over the United States. But how can an individual find all these options near them? We all travel on the weekends, we all go on vacation, and it can be difficult to find the gyms near us. This application aims to provide a solution to this problem by locating gyms near the user's location in Fredericksburg, Virginia. So I briefly wanted to discuss the data and graphics used within this web page. There are three feature layers: gyms, parks, and counties. In total, there are 25 gyms in Fredericksburg. They are all represented by different colors. This was so the user could easily distinguish between each, and when the user clicks on these points, an info template displays the name, address, hours, and website link for each of these. The second dataset, parks, is represented by the green. The opacity to this was set to 0.5 so the user could see the streets underneath. And when a user clicks on these parks, an info template displays the park name. These can all be seen here on the right-hand side of the slide. And lastly, counties was added. Fredericksburg, Stafford, and Spotsylvania were added, and these are represented just by the small black line. So before I show you the web page, I just want to talk about the web page components, just a brief overview. The overview widget is used, feature layers are used, searching for gyms based on name is used, the grid is used, geocoding is used, and display travel time based on user input on the horizontal slider using service area task is used. So now let's go ahead and take a look at the application. So when you load the application, this is what you see. As stated previously, when I click on the gym points, I can see the name, address, link, and hours of each gym. And when I click on the parks, just the name comes up. So the topo base map was used here. You have the overview widget in this top right-hand corner. Here we have this left-hand pane. Here you can see just an image added for visual appeal. Here is where you can search based on the gym name. And this big box here is where you can enter your address to see where you are in relation to the fitness facilities after clicking this I am here button. And lastly, this horizontal slider, which is how you can determine the drive time. So to start off, I would like to talk about the web page and how you can search for based on gym name. So here, let's say I wanted to be generic and just search for fitness. So I hit that search button, and as we can see in Fredericksburg, many of the gyms have the word fitness in their name. But let's say after clicking around, I see the Kennel or Monsters and Machines or Latitude Yoga. Let's say I'm super into yoga. So I see that and I type in Latitude. I can search for that. Give it a second. And Latitude Yoga Company comes up and you can see the address. So this was all done using the find task, as you can see from this slide. We have also done this in class, so this may seem similar. Here I'm establishing the columns for the grid. I am creating the grid and I am setting those parameters. And lastly here, my do-find function, which is how I am searching for those names in the actual attribute table. And then here, as I stated, the overview widget, this is the implementation for that. Obviously, key here is using that overview map digit dot startup. in this image here, showing the feature layers and how I was able to load all of those and the info templates, which we've been doing all year. So next, the second component is geocoding. So let's go ahead and take a look at that. So obviously here, a individual can go in and type their location. So let's say I'm eating lunch at Capital Ale House, Fredericksburg. I click this I am here button and this circle pops up with my location. So again, this is all done in geocoding. And here is the implementation for that. It is again similar methodology to Lab 10, and from one of the class exercises, I used the ArcGIS REST services locator. And here, instead of the addresses to location, I just did the address to locations to load the address. And this to the right is the function that I created to do so, again using that single line input. And once that is entered, once the I am here button is clicked, a symbol displays the user's location. And I will show you my full script at the end of this presentation. For right now, just screenshots. So the last component of this web page is the drive time. So many people want to go different distances to the gym. Some people only want to go 10 minutes. Others are okay with traveling farther. So I've created this horizontal slider, and when the user clicks, a service area is created so they can see how far that 10-minute or 15-minute drive time distance actually is. In this image to the right, you can see the changes from a 10-minute, 5-minute, 10-minute, and 15-minute service area. So real quick, just before I show you, I want to establish what a service area is, and this is any location on a network. And a network service area is a region that encompasses all accessible streets. So for instance, the 5-minute service area for a point includes all streets that can be reached within 5 minutes from that point. So now I can go ahead and show you this the web page. So let's say I'm at Cap Ale. I'm okay with going 15 minutes. I can click this point, give it a second to load. And as you can see from that 15 minutes, I can go pretty far. Let's zoom in. But let's say, you know what, I'm only okay with going 10 minutes. That drive time has now decreased. And obviously, as I am in different places in Fredericksburg, the traffic isn't as bad. So let's say I'm over here on William Street. It looks like it lessens. I'm over on Cowan Boulevard. Again, anywhere that you click, you can see. I'm 15 minutes. So wherever you are, this will go ahead and calculate that drive time distance for you. The max time here is 25 minutes. This was chosen just because Fredericksburg is not a huge city. Generally, you can get most places with 25 minutes. And personally, I don't think many people would be wanting to travel more than that allotted time. So now let's go into the implementation for this. Again, define distance. This was defined distance around the location using streets, and it was implemented similarly to the Lab 10 buffers, but based off driving distance. And this was used using the Esri task service area parameters. And again, this was established using this horizontal slider. And if you want more information on this, you can follow this link here. It's just a developer's page. I think we've all become pretty familiar with this, but I went ahead and linked you to that just so you can see. And more implementation. So for this service area parameters, there are a lot of parameters. Here I have only included 5: the declared class, default breaks, out spatial reference, output and for output poly and output polygons. Um, and so all 4 of these I use. The declared class is just the class name. That default breaks defines the number of breaks, and the out spatial reference is similar to what we did in Lab 10. This is what you want that spatial reference to be returned in. And what I thought was pretty interesting is that you can change the output polygons. So when I click, that can be changed to none, simplified, or detailed, and this research uses the simplified. So here, I just added a snippet of the code where I'm establishing that click and that new service area parameters. And this is new. I actually did not know anything about this. So how did I come across it? I came across it by exploring the developer's webpage when trying to figure out Lab 10, and I thought it would be really cool to add to this project. So now we have some time left. Let's go ahead and take a look at the code. So let's start from the beginning. Here you have the requirements loaded in, and we can see the base map being called, that topo base map, and that overview map widget being called in, and inserting the data as the info templates and then the feature layers, and adding these by layer. Obviously, by now we've all become pretty familiar with this. And here, creating that bind task. So here, I'm also creating that grid, establishing those columns. These 2 fields are the names and the actual attribute tables on ArcPro. And here is that label for the grid itself on the web page. So the address and the name. And here I am creating those parameters to search the data. Again, this is the same field as here, so I'm searching that username and user street and to return to the grid based off of the user search. So here I am beginning that service area task. So when I click is when I want that service area to be calculated. Here are some of the parameters that I discussed earlier. And I tried to create a function that updated the label on the horizontal slider, but I was not able to get that to work. And then lastly, that for the service area task, this is solving that. There are a lot of good tutorials on Esri that you can go and you can see this, but here I'm creating that symbol as well, and I am solving it based off of the parameters that I established earlier once I click that once I click on the map. So now I'm going into the geocoding. This is all, again, based off of the Lab 10 geocoding, and you can see I use that address to locations as stated previously. And lastly, I have the HTML portion of the script. I'm creating my left-hand pane here. Here is the horizontal slider. Again, more horizontal slider, and ending the code here. So that is all that I have for you all. Again, I want to thank you for watching this presentation. I had a lot of fun making this project, and I look forward to hearing your all's feedback. Thank you.